Okay, for the external, you need to have a little bit of knowledge about sampling. To be fair, this is something that's covered in more depth in other standards within the course. So in the intro topic earlier this year, we talked about sampling in depth. But to refresh your memory, it is worth, and you need to go back and watch these videos. So each video, one of Dr. Nick's videos, so they're about 7 minutes long each. Go through and look at those again, just to refresh your understanding of, firstly, sampling methods and why there are different sampling methods. If there was a perfect sampling method, you would only have one. So there's benefits and things, and also things that are detrimental by doing each of the sampling methods. The other one's talking about a variation in sampling area, that no matter what you do with the sample, you always end up with an error, or you always end up with something that's different from the population. And that's not necessarily a bad thing. It's more important of how representative that sample is. The last one is non-sampling error. That are things that are in our control, that we, by our sampling method or by the way people behave, can make our samples have errors within them. So really important to go back and watch those videos before you carry on with this one. And if you've watched those videos already, then we'll carry on. So I just wanted to summarize a bit of what was in the sampling video. So sampling is obviously important, that when we are collecting data, we usually take a sample from the population. And what we use the sample for is to make an inference or to make a prediction or an estimate of what the population looks like. So here's a good illustration of what's going on. So we've got a population that's a mixture of people. So we would hope that our sample would be representative and a mixture of people as well. So if we were able to get a statistic from here, we would be able to work out what it is, or estimate what it looks like in the population. So we would use our sample mean to predict what our population mean looks like. And also all the other things like the upper quartiles, the spread, the shape, and all the other things that we use to talk about a population. So what do we need from our sample? We need it to be representative. So if it's not representative, then it's not very useful to us. And also the amount of representation, or how closely it represents the population, will depend on how accurate our estimate needs to be. So, for instance, if we only need to know roughly what the average person earns of the population within $10,000, we may not need a representative sample as if we needed it to know it to the nearest $1,000. The other thing is it needs to be free from bias. And the key thing to note is that bias is not the same as fairness. A lot of the time in Year 13 reports, student reports that I read, there tends to be a bit of confusion what bias actually means. In a statistical sense, bias is simply that not every member of the population has an equal chance of being selected in the sample. And that's not because of any prejudice or anything like that. It may just be the way the method we chose, or that sampling error, that we end up with something that's different. So when you talk about bias, it's different from fairness. It means that our sampling method meant that there wasn't an equal chance of everyone being selected or being able to give their data towards the sample. So the key questions whenever we have a sample: is the sample big enough? Okay, the bigger our sample, the more confidence we have to estimate the population. So again, depending on how accurate our estimates have to be of the population, will determine on how big our sample is. Obviously, bigger samples come with it greater costs, greater time, and all those sorts of things. So we need to make sure we're using it as efficient as possible. If I only need to know a rough answer, I might take a really small sample, get it done quickly and get the information. But if I need a detailed, more accurate answer, I might need a much bigger sample to be able to answer that question. And also to have confidence in that estimate being close to what the population is. The other thing, of course, is the data representative, and my sampling method is really important to determining whether I get a fair representation of the population. Some sampling methods, it's very easy to select people, or people self-select with that end up making a bias within in our sample. So the classic example is, you know, if a liquor shop moves into your local neighbourhood, and you take a survey of, or an open meeting for people, that people that come to that meeting or take the survey aren't necessarily a representation of the whole population. They tend to be people with strong opinions and are ready to voice their concerns. Other people who don't have strong opinions won't go to those meetings or won't fill in the survey and those sorts of things. So the sample you get from that survey is biased towards those people with those stronger opinions. Illustrating the point as well, is the data biased in any way? Again, the sampling method's really important. So in Dr. Nick's video, they covered looking at the different sampling methods: simple random, convenient, systematic and cluster sampling, and also stratified sampling. So it's really important you've watched that video. It goes through really well, each of them. They all have their benefits, like for instance, looking at systematic sampling, that tends to be for in factories or things where we don't, that there's a continual pattern. Another good example would be looking at border crossings, things like that, where you don't have a set number of people, but you just have a procession. So you could, for instance, drug tests, you could take every 5th person or every 10th person to go through the gates, they get tested, those sorts of things. Convenient sampling of those mall surveys or phone surveys, or people within a certain direction. The classic example is the news report, where they're standing on the street just asking people what they think. It's not a particularly representative sample, but it is a sample. Simple random sampling, which is the one that we're relatively all familiar with. You just get your sample space, you number it from 1 to whatever it is. You randomly choose the numbers of the size of sample you want, and then you take those people out. Obviously, with geographical spreads and things like that, it becomes difficult. One solution to the geographical spread is to use cluster sampling. So cluster sampling takes, you randomly choose one area, and then you take one person or one data point, and then you choose everyone around it, so you're not having to travel to lots of different places. The other one, which is preferred if possible, looking at stratified sampling, where you divide it up into different areas and select randomly within those. That's really good for looking at demographics and things like that, different ethnic backgrounds, socioeconomic backgrounds and things like that. You can ring fence one particular group who might represent a certain number within the population, and make sure there's that same proportion of people in your sample. So it's really important to spend some time thinking about sampling methods and how that affects how representative your sample is. So in your OneNote, there is a worksheet for you to complete. So go to the lesson page and complete that, and don't forget to upload your answers onto the page.